record this meeting, so I'm recording the meeting now. Chapter 8, Architectural Acoustics. Introduction. So a little bit about the history. And you'll get some of this from your book, although you'll have kind of a smaller version of it. So we have Vitruvius, who was a Roman architect, and he had figured out that noise reflected off of certain hard surfaces. That's a way oversimplification of all of the things that Vitruvius did for us, but we'll give a little bit more on him in a minute. Wallace Clement Sabine, he did a more intimate study of the reverberation of proportional sound to volume and how it's affected by furnishings as well as boundaries. Also in this chapter, we're going to be looking at acoustic codes and standards and what are our roles as designers within this. So whose job is it? Is it the architect? Is it a sound consultant? Where do we fall? I kind of created an initial chain to give you an idea of where we're going. So we have, starting with the architect is usually the source. So he's assigning what materials he wants to use to build, and then he will hire in a sound consultant, and then at that point the sound consultant will offer him certain opportunities or different types of materials to go over the actual architectural materials. Sometimes the sound consultant is in control, which we'll see with an article on Toyota did a couple of buildings where they were involved in the sound using their sound modeling information, and they talk about how with all of the technology we have now, not that the architect will ever be obsolete, but he's kind of getting less control, and now it's more the designers and the consultants who are coming in with the better technologies and informing his decisions on what the best useful materials will be. The designer, I put them at the end of the chain, so unfortunately there we are, but that really depends on the client and the architect. So some architects are a one-stop shop. Oftentimes we have some great local South Bend architects, and I'll be passing by a house when I'm out on my parents' boat in the river in the summertime, and I think, oh my goodness, I know exactly who that architect is, because I can tell from his downtown South Bend buildings, his contract commercial buildings, as well as his residences. He always uses round windows. He uses a certain type of shingled siding that's kind of a light golden brown, basically. He uses the same angles. Sometimes he'll incorporate some of the rain chains into things. So there's a couple of local architects actually that I can recognize by their styles, and those are the architects where they feel like they're artists, and they most oftentimes are, but there's some who are much more concerned with just the site activity and basic site structure, and then they want to hire in their own designers because they're not into the very much the artistic part of it. Sometimes the sound consultants will force a designer into a position where they say, here's these really ugly options for you. I'm going to show you some product. You probably shouldn't, because I don't think we're supposed to do it. I can show you product and be product specific, but I don't think I'm allowed to say anything's necessarily ugly. So I'll just put it on the screen and you can decide for yourself. But you might be led in a certain direction subconsciously against your will. But there are some ugly options out there, right? We get into this portion where we have, especially with sound control and acoustics, you can have this interesting looking waffle-like material that you picture from, let's say, the 60s and 70s being on roofs and walls and type of sound booths, or possibly in some types of cars and vehicles. It's kind of like that honeycomb foam. And there's people who will still try to sell you that today as a viable option. They'll just paint it blue and say that it's now designerly. But there's hundreds and maybe even thousands, definitely thousands of options that are better than that. It's just, do you want to pay for it? So we'll take a look at a couple different types of options tonight. Room acoustics. So we have, underneath acoustic codes and standards, there's different areas to concern ourselves with, such as room acoustics, sound isolation, mechanical equipment, and sound systems. We have to have the context of which part of sound and acoustical codes are we dealing with in order to place ourselves? So we're mostly concerned with room acoustics. We don't touch much on sound isolation, although it's part of room acoustics. Mechanical equipment and sound systems, those more technical things will leave to the engineers as well as the consultants. And then there below you see I have the arrow leading to room acoustics, including the acoustical environment within a space and isolation of sound between the spaces. So we'll see more of that in our homework assignment, and I'll talk about that at the very end of the night. So let me start. There is assistive listening systems as well, but there will be a slide later. History. So Marcus Vitruvius, he wrote the book De Architectura, and within that he has a couple chapters, although I'll call them chapters now, subdivisions of different books within a larger book. So book 5 specifically talks about these types of ceiling pots or acoustical pots, or oftentimes they're actually referred to as acoustical jars. The book refers to them as acoustical pots. Within my history background and art history background in architecture and history, we would see them more being called acoustical jars. But here's an example of those. So he, as I said very briefly before, was the person who started to think about more of sound as it reflects off of hard surfaces. And even before him, we have Aristotle. So I don't have a slide for Aristotle, but I'll give you some background on that. So Aristotle, and this is just astounding to me. I just think it's astounding without technology what people were able to deduce just by observation. Science astounds me, so I'm so much more arts oriented. But Aristotle knew that air carries through sound, and the fact wasn't verified until we have the scientific method in the 17th century. In the 1st century AD, this is when Vitruvius ran with the idea that Aristotle initially had, that air is at least carried through sound, and he began to show us how to enhance sound in halls by using these varying holes in the ceiling that led to some type of round pot. And he played with the materials of pot used, and he found that he had better sound effects when he would use different types of metal. So better to make the pots brass. But clay worked as well, which we see over here in this sidewall. This is one of the clay pots. You can still find acoustical pots, actually, as late as the 17th century. And we use variations of that idea even today. We'll see a little bit of that as we go on. And then here's just a drawing out of the book in chapter 5 where he was trying to figure out the acoustics within a musical hall of the time and where he was going to place those pots within the different chambers in the space. So we have continued history with Wallace Clement Sabine. So here's a picture of him to the side. And he was trying to figure out acoustics specifically within lecture halls and music halls. So he was experimenting on the campus at the time, and you'll have a little bit of this background in your book, with taking cushions from the theater on his campus and then coming into different spaces and carrying those cushions inside, placing them around the varying tiers of seating and on the floor to trying to see how it would affect the sound in some of these rounder, concave, roofed spaces. And then he would move them all back in the middle of the night so that they were back in the places when the people got ready for class the next morning. Here I have an equation. You have to memorize it, and there'll be a test on it later. So that's in the lower right-hand corner. Not really. Thank the Lord, we don't have to do that. But I do have a website on him. So let me pull it up really quick. And I just want to read a little bit off of it, and I've included the link for you. So Wallace Clement Sabine, he was considered the father of architectural acoustics. He attended Ohio State University, so he studied physics there. He later went on to Harvard to pursue his graduate studies. After graduating, he joined Harvard as a faculty member teaching physics. Sabine never, had any formal training. He became fascinated with sound and how it differed from one lecture hall to another. And then I'll skip over all this extra stuff. I've included the link for you. Here we have Sabine came up with the formula determining the quality of sound in a lecture hall, auditorium, concert hall, and any other venue where people spoke or played music. So here we have him finding that 2 to 2.5 seconds was an optimal reverberation time for a concert hall, and 1 second was the optimal for a lecture hall. If a lecture hall had a reverberation time of more than 1 second, students would have to contend with multiple words at once. Isn't that crazy that he figured all of that out? And he did just varying activities of changing the absorption by adding different materials into spaces and placing them around. There wasn't a lot of technology to help him come to this conclusion outside of physical placement and example and trial and error. So here we have just pictures and images. It says the following reverberation times are different for concert halls. So the Boston Symphony Hall has a 1.8 seconds versus Carnegie Hall in New York City with 1.7 seconds. And here we have Sabine's formula. This cracked me up. So they showed the formula, and then they start explaining it. And they'll say the unit came in the dimension area, 1 square meter surface absorption coefficient. That would be considered 0.75 Sabines, so lucky he named it after himself. The coefficient has a range from 0 to 1, where a coefficient of 0 indicates none of the sound is observed, and 1 indicates 100% is absorbed. Since we know the speed of sound is 20 degrees Celsius and 340 ms, we can do a little math and reduce that formula to this. So that cracked me up. We'll just do a little math, and boom, there we have it. And then they go on to explain all of the significance and how he was able to figure out the differences between talking levels versus music levels and all of that in between. So very interesting man, and continued link provided within the PowerPoint right here under his picture. So on top of that, I said earlier, we have assisted listening systems. So we have assisted listening systems that are required in assembly areas where audible communication is integral, and the person who is responsible for implementing these acoustical assistive listening systems would be our sound engineers. They will fine-tune the systems. It's not even necessarily the designer's responsibility to implement these. It's kind of assumed as an actual code that's set forth by the ADA. So it wouldn't be something that we would concern ourselves with unless we notice that for some reason it was lacking, and I'm highly unlikely that an architect wouldn't have made it to that point just based off of the code to begin with. Oh, I just had a noise in the background, but it doesn't look like it's coming from our actual class. Alright, so we have these within assembly areas with 50 or fewer seats, and it requires at least 2 receivers, which must be hearing aid compatible. An additional receiver is required for each 25 seats up to 500 seats, with more for larger quantities of seats. Selecting or specifying an effective assistive listening system for a large complex venue requires that sound engineer. I have one example here, and here's a company where you could purchase them. So you can see there's the device that is emitting the assisting sound, and then each individual who's in need of assistance would have one of these devices that they could plug into in order to hear better. Oop, don't get too far ahead. Design process. So within the design process of acoustic design, we have acoustic consultants who are often brought in for music halls, education, and libraries. More and more now, a field that I think has been primarily led by the designers, but we're realizing in order to have the best experience, we need to bring in skilled acoustic professionals first, is dining. So I have noticed, especially locally, we have this trend. Like I said, we're building kind of these echoey fishbowl environments. We talked about last week in the work environments. We have a lot more glass, especially brew pubs. So where they're popping up everywhere, and they are the main perpetrator of large glass walls to show off their brewing equipment, and then cement floors. Oftentimes the cement floors have some type of decorative element, which they have some pitting and more physical separations, which isn't as helpful as you would think. Sometimes it adds extra concave surfaces in the ground, which reflect sound in a certain way that's not appealing. But they also have these exposed ceilings. So we have a larger plenum without any room for insulation within the ceiling tile area because they removed the tiles to expose all of the piping. And on top of that, you just, by having in a bar environment or restaurant family dining experience, this is even worse than I feel a bar environment where we have the two combined. So you have a lot of kid noise, you have a lot of people who are drinking a lot, noise in the same spaces next to each other. And then add that element, I'm thinking of a specific place that was recently put in, that we were called in to help. Another element is live performance music. So you have all these brew pubs, they want to have the family there, they want to have just their normal drinking crowd, and then they want to have this element of music. We will learn in this chapter that different types of sound and how it carries. So how we just talked about with Mr. Sabine, how he realized by using different acoustical materials, you have a certain amount of time lapse that you want if you want to have everybody in the room hear that music. Having more reverberation is actually great for music, but it's horrible for maintaining conversation level in which you can hear the person next to you, but or the person right in front of you, but not next to you. So you can't really successfully do both things in the same location. I'd say that's a pretty good general statement. It can be done, but very expensively, and you're not going to see it a lot in our dining experiences locally, and I think it's a big fail in the design process in trying to implement all three of those together. So room acoustics. There's acoustic fields, acoustic reflections, and openings, all that we have to take into account. So acoustic modeling is one way that we can try to better understand our environments. This acoustic modeling is done by those technology experts in the field. It could be a sound engineer. It could just be a basic consultant. I say basic consultant because I've done some things in my career that you would never expect someone of my background to do. So I was just thinking about that today when I was trying to think about your homework. I've had multiple times, because as designers in this program we'll be asked to do a lot of design details. I was asked in my field, I was creating the entire finished environment. I had picked all the furniture, and then they would have some type of AV equipment. By AV, I mean computer tower or speaker system. But they didn't want it to just be sitting out within the environment, so they might have had a classroom and they needed speakers at the back. So they asked if I could design a box that would house those items, but would also allow for venting so that they wouldn't overheat and would be beautiful as well. Never would have thought I'd actually have the opportunity to design that. So what I would do is I would work with a cabinetry maker, and then I would end up picking some type of, and we'll come to this, acoustical fabric, if it was a speaker system, that would be reflective that I would apply to the front. I would try to figure out the venting, knowing that heat rises and cutting slits in the back in the upper portion, but my AV informed me that you don't just need to vent at the top of something, you need to vent at the bottom so that you get cross circulation when you're dealing with heat venting out the back. So when I say it's not always a sound engineer, sometimes you have people working for companies, like at the bottom link of this where it says Auralex. Auralex is a company that provides sound measurements. So they'll come in if you say, my office is too noisy, would you send a sound professional? They're going to send somebody at about the level of me who might have a design background or a graphic art background or maybe possibly some type of engineering background, but it's not a requirement. But the real requirement is that they, like us, have memorized and fully know how to learn special technology associated with this acoustical modeling. So I have two images on the screen. And one of them, the first image, is a type of acoustical modeling where you could build kind of as if it was an AutoCAD or a Revit. You would set the parameters of your building with the outer wall, and then you could put in seating or you could put in ceiling parameters. And then after you have all of those in, it'll do the measurements of how varying levels and frequencies of sound are bouncing off. So not that it doesn't take a lot of previous knowledge, it just takes knowledge on how to use this technology. And that's so much of our career, is learning new technology all the time. So we would work with an individual who has at least that background, if not a full engineering background, to do this. This image to the right is showing a space, and this is showing pressure within a space and thinking about how sound within air is affected because of that certain pressure within a space. So there's tons of measurements they do. Outside of even these, we'll see when we visit the Auralex website. And I just want to walk you through that for a minute so you can see what you might experience in the field as a designer. So I worked with them when I was in contract design. This is their website, Auralex Acoustics, and I am on the absorption page. So it says the two most commonly used sound absorption materials are high-quality acoustic foam and specialized acoustic fiberglass. And we're going to talk about fibrous materials within our chapter. So it says, no, not the stuff you buy at the hardware store. For brevity at times, we'll generically call acoustic foam just plain foam, although there are very dramatic differences in cell structure and density between acoustic foam and the thousands of other types we could manufacture. So here you have their product. Lovely. You have flat foam and flat sheet, sonic shell, sonic fiber. So this to touch is less of the foam. This is actually kind of like if you have a scoring pad at home where it's sponge on one side and kind of scoring pad on the other. It's a little bit softer than that scoring pad, but the same kind of weaving pattern where it's that curly Q interwoven. And then T-acoustical ceilings, which we kind of talked about last week some. And then here you have the very much foam that you might see inside, specifically a sound booth. See how it says studio foam. So there are applications where there just aren't better options. Beautiful studio foam is really hard to find. They might have different colors, and they do. I know that they have beige, black, green, red, blue, but you'd be surprised how little variety most companies offer in the area of studio foam. Lots of shapes, which we'll see kind of in the Toyota article that I talked about earlier. So lots of shapes. Now, they also do Sonolite clouds, which I showed you last week, Armstrong's product. And we see quite a difference between Armstrong's product and their clouds. So this is where I'm talking about cost effectiveness, although we have to weigh again our sustainability into all of this. So maybe this is, I'll say, less beautiful than Armstrong, but which has the higher recycled content, which has the better fire rating. There's so much for us to consider. And sometimes that job really does fall onto us, especially with fabrics on chairs. Sometimes when we've got through an entire bid, we'll say in a project, a bid where they asked us to specify all the furniture for a hospital. And I picked all my fabrics, and then I got to the very end, and I chose them because of their light fastness, so they wouldn't, there's lots of windows, I didn't want them to lose any of their color. I chose them because of their fire resistance, and then I write all of that in my specifications, but then they asked me for the actual fire resistance sheets, which sometimes they will and sometimes they won't. This specific building was in Chicago, and Chicago has much stricter codes on that. So I had to go back to the website and download all the specifications on fire safety and how it passed it. So that can be our job. It's not always just falling to the architects. And we want to research before we get to the very end and hope that it all works out. They do supply us with these renderings right in here, so Pro Panel Pro Kits. That's where if you want to not hire someone, now you can hire them to come in and they'll do measurements, which we'll read about in a minute. Or you could buy these Pro Panel Pro Kits where you just say, I just need to throw up X amount of panels onto the wall, and they'll send you so many in a box, and you can apply it yourself. Because any real acoustical treatments will help. I've specified 2 to 3 pieces of acoustical artwork before, and it did help out the situation, and there was an entire glass wall. It's just if you really want a professional to get it 100% soundproof, that's a whole other story. So we could go this route, which is a little less expensive because there's less measurement on their side. I have been asked myself, okay, so here's where the question is. Now that we're into this territory, so I'm talking with Auralex, and I have to supply them with things because they don't work here. They're based out of wherever they're based out of. We could look at that on About Them. I can't remember right now, but let's say Indy. I could pay them to come up, and they'll do all the measurements of my space, and they'll take a time out of their day to do that. They'll send me an email with a drawing like this. Sometimes if we want to save money, I will do the drawing like this. And I'll do it because I might think that it'd be more beautiful to have 4 of these tiled, 2 on top, 2 on bottom, than 3 here in a row. And I have an idea, so I'll send them my SketchUp or AutoCAD or Revit idea of this space. And then they will, for free, because I've already done most of the legroom, say yes or no, or you might consider changing this. So we can save money depending on how much labor we want to put into it ourselves, and depending on what relationship we have with the client. So they'll send you some of these. They have Sonic Print, but this is a much more expensive solution than some other solutions out there. And it's kind of a trial and error process when you're in the field, unless you have a reputable seller of product that you've experienced in the past. Acoustics is becoming more prevalent than it was before, and there's a lot out there, and you can't know until you test it. And here's the fasteners. You have to pay very close attention to the fasteners again. You know, is it impaling clips that's going into your drywall? Do you want to have all of those holes? How easy are they to remove in the future? They have freestanding product. All right, so here's our job. So I could have done this work to begin with, but let's say I don't have time. I have 100 things that I have to do. I have 5 spaces I'm designing, so I want them to work for me. So in that case, our room analysis services. What do I need? So I would send them, and really anyone can do this, but we're more equipped to do it because we know AutoCAD. So they say, get free immediate results for small, simple rooms. For all small room types under 700 square feet, receive up to 3 different treatment options for your space. A new construction calculator. They have free room analysis for larger, more complex spaces needing a personal touch. It covers all room types and sizes, including scale of commercial facilities. Submit your information about your room, and the application specialist will create the drawing packet for you. And then they have a more in-depth analysis that has testing kit with omnidirectional microphone and downloadable frequency sweeps. So they'll send you part of that kit and you'll run it yourself. Or the most accurate way is to have an acoustical consultant visit the actual space, take the measurements, combination of subjective listening, objective tests that yields the most accurate and functional results. My business paid for this last one because we were having issues where we had the webcam, kind of like what you were seeing today with me, but the room, whereas now I'm fairly clear because of the acoustics of the room, on the other side they were constantly getting this echo where they were hearing like 10 seconds after what we said. So we had to change the acoustics that we didn't get the bounce all the way around the room and then back to them. So we needed the professional to come in. We didn't want to waste money doing this and not having it be successful. But we did send them AutoCAD drawings, which then they immediately sent us back 3 versions of the space. So the more drawings you're able to send a company, the quicker they can have the turnaround of your information back to you. And then they have an Express app because everyone has an app for everything now. So this is a good resource. Not for every application. I would see using Armstrong over them for more beautiful applications. But for sound rooms, recording studios of any type, they're a great resource for you in future projects. And this gives you an idea of your day-to-day work. someone asks you to check an acoustics and you look like the hero because they don't know about this company, and then you send your CAD drawing and you get 3 different versions. You decide if they're beautiful enough and then you forward it on. So we do the drawing side and work with the company. And that's usually how it runs. I need to get all this stuff out of the way so I can click on this guy. Okay, so acoustic fields. This was another article that I wanted to bring up from Architect Magazine. The book was talking about, whether we have convex or concave surfaces and the difference in the times that I brought up earlier in speaking versus in music. I thought that this article specifically did a good job of talking about a true life application of that, and with a company that we're fairly familiar with, except more so we think of it for cars than we do for acoustics. Why am I having such issue with this? There we go. Let me make sure I don't just have it looming in the background. Physics. Okay, let me type this one in. Sounding off. Okay, so Toyota, who prefers to keep his process secret, says that only the software has improved so dramatically in recent years. Until the last 10 years, we didn't do a very good job. So here they were trying to figure out how they were going to have this music hall properly made. So they have the convex surface that's going to bounce sound, because they're specifically trying to get the low frequencies of sound to do the right thing. And we have to think about low frequencies versus high frequencies. High frequencies are going to move throughout the room well enough because of all of the hard surfaces, so the arms of the seating, the floor, the planums of the wall, the planums of the ceiling. But those low frequencies, they don't move fast enough, and they end up bouncing and then just stopping if they don't have the right type of bounce. So that's where we have to do more planning. You saw the difference in materials today and in last week's session of how beautiful versus non-beautiful they can be. And I found in the field that working with sound technicians is the area where you're most going to get told, we can't do it any other way, or it cannot be more beautiful than what I'm showing you. It has to be this way for it to sound the best. And I think it really does all come down to money and really the territory that you're in. So we're in the West, and we don't have a lot of product here available to us. But eventually I feel like we'll get there, and it will become cheaper over time. It's just that to do something as beautiful as this within the bounds of doing what they wanted acoustically is very, very expensive. So it says the use of sophisticated modeling software, including non-proprietary programs, helped in designing the spaces where sound is important and largely driven by data. That means architects are likely to have less control of the overall design process than they might like. Still, the best consultants help apply the data to realize the architect's vision. And then here, as we continue down, here it says avoiding echoes was also a goal at the Temple of Beth Elohim in Wesley, Massachusetts, where Kierkegaard Associates was the acoustical consultant. They had a square sanctuary designed to take advantage of the woodland views. 2 of its four walls, nearly 70 feet long and 40 feet high, are glass. The effect is dramatic, but the danger was that the sound would bounce back and forth between the glass and other smooth surfaces. So the solution was to ensure that part of the interior walls were angled slightly and other parts were covered in panels. And it was consisting of perforated wood veneer or absorbative backing. I have a picture of that on here. So here is the watercolor rendering of that space, Temple Beth Elohim. Let me type it in and see if I can't get you a better real image. Oh, no. Just click, click, click. All right, so there you can see the large expanses of glass that they were worried about the bounce going back and forth between the two. But all they did, and you really can't tell from the exterior, so it must be an extremely slight angle that they applied to the building, just enough to stop that bouncing from being a straight-on bounce across. And then they ended up applying that perforated backing so that it would help the sound to die off and not cause such a reverberation and absorb some of it. So sneaky. I mean, it doesn't have to be a big design difference. They just slightly angled it, just off a couple of degrees to change how the sound was moving. And I supplied that link as well. Also, Lost Art. Everybody take up watercolor rendering for future projects. I really do. I miss that. I remember seeing people do that in the program when I went through. Not all of us, but some people who still did it that way. I feel like architecture programs still have some slight focus on that. So building noise control, controlling exterior noise. So when we have exterior noise problems is where we're starting to see those large expanses of glass more and more, as well as we're starting to see opening up spaces so that we have the open office environment and we have less separation between certain interior areas that are already noisy, as well as less separation from the exterior elements, such as we said making sure you don't put a hospital next to a very busy park, or even if you have a parking lot, you want to have a buffer between that and your main work area. And then thinking about what's going to be built in advance. So if they're going to build a freeway or a highway running by to one side, eventually you don't want that to happen. So we have to have quite a bit of forethought going into it. Interior planning. Oh, 1 second. Level.org. Sorry, I don't want to move on yet. So trying to supply you with good resources that are helpful to supplement the book. Oh, and this had great pictures, yes. So passive design. So that's the continuing theme, right? Instead of active systems, mechanical systems, we're trying to incorporate more passive design, less electronic systems. So for noise control, we want sound attenuating external walls, sound attenuating roofs, and sound attenuating external doors and windows. And they provide you on this link examples of the wall sections of those constructions and how they help with the sound. So high-density sheet cladding with sealed joints, thermal insulation, and sound attenuating interior lining will provide sound reducing lightweight construction. And then a brick or concrete masonry veneer with a rigid air barrier, thermal insulation, and sound attenuating interior lining uses heavyweight construction to provide effective sound reduction. And then here we have the use of concrete masonry, which is just as effective. So you have multiple options. It's not clear-cut as some may think. We have tons and tons of different architectural selections that can be made in order to help us in killing that sound problem. So here was good sections. So this is the idea of a section detail, which we'll see for our homework. And then more information. So controlling interior noise. Equipment noise, mechanical system noise, and plumbing system noise. I feel like we talked about this enough last week, and I gave you more links, especially how it related to healthcare, and then those articles focused on each of the systems you're dealing with within the built environment and how to prevent them from becoming an issue. To the side, I've just laid out pieces that might be included in your plumbing system and how those different pieces could affect it. So in the upper left of those images, I have a plumbing fixture that would allow it to move around a little bit. So that middle piece that kind of looks like a rolling pin is really a rolling piece. That's what they call it. They call it a roller. And this would be fit around the pipes and connect it into the ceiling or into the wall, but it would allow for a little bit of movement if they were ever to need to go in and correct the fitting, or allow for it to kind of move with the flow of water pressure. And then to the side of it, I have a different type of resilient pipe hanger. And these pipe hangers can come in metal or in metal fitted with rubber on the bottom. So as they're being shown as if they were hanging from the ceiling. That central part is what would screw into either the wall or the ceiling, and then it will hang and the pipe will just be suspended within it, kind of like a little, I don't know, I don't have actually a good illustration for that, but you're seeing a cut through section of the middle part, so that's the pipe in that bottom circle, and then it's hanging off the fixture. And then putting rubber on the bottom where it's resting would also help with the shake and the noise reduction. So not all of those resilient pipe hangers are created equally. The less metal and the more rubber that we can implement will help us with the shake and the sound problems. And then the lower right, I have a flexible connection. So some of them are more rigid and involve more metal, and less flexibility can cause for increased reverberation and noise problems. So using these rubber fittings that also have a little bit of bend to them will help. Background noise. So rating background noise levels. We have a table 8.1 in our book, which I'll show on the next slide. Oh, I lied to you. I think it's 3 slides because I added in 2 extra slides today. So here's that table 8.1, residential and office NC, which stands for noise criteria ratings. These measurements are just showing us the difference in the noise criteria of the apartment house, private homes, hotels, private offices, open office plans, and conference rooms. So we can see the most that we have is taking place in that open office plan that we talked about last week, and for all the reasons that I had mentioned of the changes in surface, the changes in material being used on the furniture, and those expanses of the planum and floor materials causing the echo because of the solid surfaces. But noise criteria is not extremely important in our measurement systems. Ways that we can help with these noise issues is we can start by trying to eliminate the source itself. So for instance, we're going to talk about structure-borne sound, and it shows a picture in your book of somebody bouncing a ball above the apartment of another person. And so we kind of want to target, that's an easy example. We want to target the source. So if we could just get the person to stop bouncing the ball, that would be our jumping off point. If we cannot, so it's a fixed thing like a mechanical system where we can't eliminate the source because it's already set in place, we're not buying a new one, it's not going to change. We'd want to then increase the absorption properties in either the materials that are built into the environment or by adding in our own acoustical applications such as the Auralex that I showed before or the Armstrong products. And then we want to modify the transmission paths. I think that's going to be best illustrated when we get into the types of paths and how sound travels later in this chapter. So that's just the idea, very simply, modifying a transmission path. Could we put a wall or freestanding acoustical panel even in addition to the architectural wall between it so that we're bouncing off some of that sound transmission in a different way? Could we open or close something that we aren't already opening or closing? Are there things built into our environment we can adjust? But also considering how sound moves through different paths in a space. Sound transmission. So there's airborne and structure-borne sound. So airborne sound. This I had next to it, Origin defines it. I think this is the most important piece of that. So the difference between airborne sound and structure sound. Airborne sound can turn into structure sound the moment that that airborne sound hits a piece of the structure. So if you have a sound that started by someone, let's say it originates from someone yelling or clapping two objects together in the middle of the room, it's going to eventually want to bounce off of that surface of the wall or the ceiling. Until it bounces off, it was an airborne sound, and really the clapping together doesn't count. Let's say it's just noise traveling from word of mouth. That's probably the easiest example. But once it hits and jumps off of another surface, then it becomes that structure-borne sound. The example that they have in the book is that baby bouncing a ball above the other woman's apartment. And that's where that ball is hitting the structure, and then the lady below is noticing the sound. Discontinuous construction, I had next to that the most important thing that the book informs us of are we want to stagger our members sometimes, our building members. So one way to stop issues with construction and leaks of sound is for us to either use flooring atop of solid surfaces, so like concrete, and we have a chart to go with that. Or if we have, was it in this class or was it in history? I think it was in this class. Yes, definitely this class. So when we want to find out where our supports in our houses are, and we were talking about possibly moving a wall to open up a space, I was saying you could continue that by going down to the basement and seeing where your main poles are supporting a space. And then also you usually have the main wall studs that run the entire vertical space of the building. So it'll be in the basement, the middle floor, and if you have another level up, the next level up, and it'll run all in a row. If we stagger those, then we're adding this point of dulling amidst that sound plenum where the board is separating the plenum just a little bit by adding the extra stud, and by staggering them, they're not all in a row, so there's not a wider expanse between studs, and it's creating a way for the sound to stop, more so than when we have them further apart in larger expanses, all running up and down vertically. Also, we have, if we want to insulate them, we could get more compact insulation between each of those members. And then there's even more detail than that within the book that you're going to learn about staggering your members of construction. Measuring sound transmission. So transmission loss, TL, mass rigidity, absorbency, denser, heavier construction equals less energy set. So that's a very simple concept of, they show it in your book as you have a wall that's created where on either side it's a 1/2 inch gypsum board, and then you have one where it's 5/8 inch gypsum board. The thicker of the two gypsum boards is going to allow for less energy and sound. So technically it's going to be the better at controlling the sound and making it so that we have less absorbency and transmission loss. There's sound transmission class, STC, which is dealing with airborne sound. It's the rating of performance of a building material or construction assembly in preventing transmission of that airborne sound. Here's where I was talking about the discontinuous floor construction. So just as we could stagger our members and thus affect the amount of insulative properties and also air gap instances and adding some type of structure to the plenum in order to cause less reverberation, we could also think of adding over concrete different types of flooring materials. So we could have thin composition tiles on concrete floor, which will help reduce it 2 to 5 decibels. Cork tile, which helps around 10 decibels. Thick carpet, which is more than 20. Wood floor finish on sleepers, which is 6 to 7. And wood floor with resilient strips of mineral wood or fiberglass under the battens, which is 12 to 14. So it looks like carpet is our winner here. But still surprising, possibly, to some of us, if we implement the right materials in combination with our wood floor, just how much it can help us to reduce the sound. So reducing acoustic energy, there's room sound quality that we have to take into account. Measuring sound absorption coefficient, SAC, the noise reduction coefficient, which we've seen in a number of previous classes, sound absorption strategies, so using absorptive materials, fibrous materials, or porous materials, installation of absorptive materials, panel resonators, and volume resonators, and reverberation. And I'm not going to cover everything so fully tonight because we have a lot to get through, but this will act as a really clear outline of your reading, and then it does supplement in quite a bit of material. So here we have a table 8.3 from the book with sample sound absorption coefficients. We have things that we can add such as acoustical tiles, brickwork that's painted, cork sheet, and cork is a material that's not used very often, but it is very much a green material and very sustainable. And then it has these acoustical properties to it that we'll see, maybe we won't see it as specifically, but Armstrong has a lot of cork ceiling tiles and types of clouds that they've created where it's just layers and layers, and it helps exponentially more than you would think compared to some of the acoustical tile properties. On here it looks different. I might be able to show you some of those varying statistics with actual product later where the cork outweighs the benefits of the acoustical tiles. Hardwood, plaster walls, plywood panels, polyurethane, flexible. We have 8.4, which shows us sample noise reduction coefficients of all of these materials with their descriptions. And 8.5, which shows us selected fibrous materials such as cementitious wood fiber panels, which are fibrous surface that absorb sound exposed on ceilings or walls to reduce noise and reverberation. Acoustical foam, open cell. We saw some of that with the Orlex. Air can be blown through the foam. Excellent sound absorber if thick. Upholstered seat cushions. Fiberglass or mineral fiber bats and blankets. They reduce noise and reverberation depending on facing and thicknesses, inside wall studs, or behind fabric or open grill. Fibrous board, fibrous spray-on insulation, and loose acoustical insulation. So under sound isolation, he'll be reading about mass, resiliency, tightness, compound barriers, floor and ceiling assemblies, and special acoustic devices. I'm not going to talk about all of these things in detail tonight. I did want to concentrate a little bit on floor and ceiling assemblies in insulation, modular sound absorbent acoustic screens. So we have some great products that I can show you later on this. I showed you a little bit of the Orlex where they had those nice metal poles that were connected to the wooden bases with the panels on top, but I think there's some better things out there. Sound transmission between spaces, walls partitions with flanking paths, duct lining. Okay, so flanking paths. I want to skip ahead a little bit because we don't have that much time because I want to cover your homework and I think there's going to be questions. Flanking paths, so thinking of duct lining, ceiling penetrations, doors and sound transmission, and window and sound transmission. This is one of the main things going forward. So here I have insulating above a suspended ceiling. Here we have our different type of HVAC and ductwork. Just going in your suspended ceiling, you will not see this a lot. So I've worked at a number of open offices and they don't go this extra space or extra step. This will really help to stop some of the sound problems between an office and possibly a break room or an office in an assembly area or conference room. This closes up that hole in the ceiling plenum just a little bit, as opposed to without it, you'll have a picture on 121 in your book where you have the less than full height partitions and really walls leading up to that ceiling plenum without any types of of insulation are going to have this direct connection almost with sound to the other side of that wall because the partition doesn't go all the way up. So adding this will significantly reduce the sound. It also helps with HVAC. We might get a little bit of reverb from that or some weird clicking noises, so it'll add a softening layer to prevent those problems. And it'll deaden some of the sound from the pipes. It talks about hammering noises that can be a product of water flow through the pipes being installed wrong, so it could help with that issue before it was corrected. And here's my gentleman installing that. I wanted to skip forward too, because I had a little diagram of flanking path. Okay, this is known as sound flanking. The sound will move from one room to another through a direct and indirect paths. It's important to understand that while sound can travel through air pockets, like ductwork, stud, and ceiling joist cavities, it can also be conducted along studs, joists, pipes, concrete, and glass. So this just shows you that we have to think about all those contact points. We have to think about the air ducts as a possible way that sound's going to get transmitted between spaces. We have to think about just the flex in the wood and the wall planums and them being in close proximity to each other in these corners. If you were to stand there, you might be able to hear sound from one space to another space. Think about those ceiling cavities and applying some type of insulation above so that we don't have the problem I talked about earlier. So many things to consider, and even if we changed up the flooring materials between the two spaces, we might help by carpeting one space over another so there's not two hard surfaces going on at the same time. Jumping backwards a little bit, and all this is covered in ring, so don't worry, although you'll have the video. As designers, on top of working with the different acoustic companies, I brought up having to create some type of a wooden box to support furniture. That might be something you're asked to do, is some type of drawing detail. And here is an acoustically transparent fabric open weave that you would use on the facing of those speaker box housings. I supplied an article, or really a source for this, the Acoustical Solutions product. And you could get varying colors and types of weaves, so sometimes they're tighter and sometimes they're looser. And you would just decide based off your product. And usually your AV or technician will help you decide what you need. Floor finish ratings, carpet pad, and how that helps. So as many layers of cushion as we can get are always useful to reducing sound. Open office cubicles. I told you that we have more glass, but at the same time we have insulated panels versus non-insulated panels. What's so funny, Gabe? Sorry. Oh, I really wondered, was the picture funny? Desk-facing opening and desk-facing partition. So thinking about orientation of worker within a space. If you have a large, expansive hall, it's just this big, flat area for sound to bounce off of, you might want to change the direction that they're facing. Here it's bouncing off of them. Here it's bouncing from one person to the other. If we add more panels in between, we can create a more closed environment, in which case we probably want to add glass or lower the panels so that it doesn't feel so constrictive. But these are all considerations that are our job to figure out and take into account before we deal with these people complaining that they hear each other all the time, and it's very annoying. There's more on corner office acoustics. And now I'm going to take a break and talk about our homework. There's not enough time in the day, guys. So let me close this for a second. And I'm going to open up our homework assignment. Okay. So it's our exercise 8. Your community center client has a request regarding the acoustics for a new facility. The meeting room will be used by different groups at different times. However, the office will be used all the time by the staff. The client would like to create some acoustic privacy separation for the office so the staff can work confidentially without the public eavesdropping on their activities. And without the public activities disrupting their work. Research wall section details showing how you would help isolate an office from a larger community center space. Pick selections that illustrate the connection between the floor slab, the wall between spaces, and I said the community meeting room and the office for us, and the wall itself between the two rooms. The ceiling connection at the office with the meeting room, or the ceiling connection, yeah, that's, I want to say it different. Ceiling connection, we'll say, of the office space with the meeting room. These should be construction quality drafted details. All 3 details must be included. Designate as many finished materials as you can, as well as the actual structure items, studs, concrete slab, rafters, etc. Consult with other source books, scholarly articles, and images for standard details for sound control to come up with a reasonable solution. You may determine the dimensions of the office and the shared wall, although they don't matter at all, because for a wall section, you might tell me the height if you're going to give me a full overall wall section, but it might just be a portion, and I'll show you what I mean by that in a second. That's just in case, that's in there in case someone was going to say, well, what size is the office and what size? It really doesn't matter. But you may determine them if you want. Materials are the main focus. Include a written explanation of your details and why you chose them / combined them. What wall materials, flooring materials, insulating properties, and absorbent properties did you take into account? Whatever dimensions you choose for the shared wall, you must also do an elevation with an applied acoustical treatment on top of the architectural wall features. Turn in all drawings electronically. So digest that for 5 minutes and then we'll talk about it. Really, we'll say what's happening is you have a small office and then it's connecting to some type of meeting room or meeting area. And I want to see, let me pull up my open PowerPoint. So at the very end of my PowerPoint, I had some examples of wall sections. I want you to do some research and try to keep them as scholarly as you can, although you might want to replay this for me later, but whatever minute marker this is of the video, if you can't find a .edu or you can't find a Google Scholar article or an image that's from a reputable company, I'll take what image you have, just give me the source, and there might be good things about it enough that I would allow it to be included. So I want to see different types of wall details. So here's a section view, and I can see clearly the floor, and here is the wall, the actual wall. I also need to know, though, what's going on at the ceiling. So it'll be the reverse of this section detail, because we're cutting through the wall. The ceiling to wall connection would be like this, flipped upside down, and then you might see a cavity of space, and then that ceiling tile, kind of like if we were to look on 121 of our book. This is a real drawn out view, but it would look like a zoomed in version of where that arc is going, where the woman's talking over. I want to see, you know, where are you using ceiling tiles? Did you put insulation above it? How are you connecting the rooms together, and what materials are they? And what you're doing is you're just researching examples of this and then picking the best one based off of your reading and any research that you can do. So I talked a lot about insulating, so that might be something you want to include. It doesn't have to be perfect. I know we haven't all had drafting, so I'm not even necessarily asking you to draft it as much as give me 3 solid examples and explain the best pieces of them, and if possible, so I have PowerPoint open right now. So say I found this one where it says acoustic fill material. I want you to be a little bit more specific. So in there I said what wall materials, flooring materials, insulating properties, absorbent properties did you take into account? What I'm asking you to do is say, here's a product that I use. So on top of just saying, this I'm going to have be insulation, you might have done some research into what that means, acoustic insulation in between walls in an office. So it's kind of a sense of wonder question in that I'm just looking for you to look at real life examples of section details. You might not have that much experience with it, so this is what we do all the time. There's drawings I have not experienced in a class here that I've had to deal with before. There's lots of resources here for you in the actual library that we have on campus. I think your book gives you some idea of all the materials that would go into making the sound acoustics better. It just doesn't give you great visuals, so that's why we're researching these sections. I think there's enough keywords within the assignment for you to Google on, where you're looking for acoustical section details. That'll be the main thing you're Googling on, acoustical section details. And then you might say acoustical section detail floor connection, acoustical section detail ceiling connection. And it should give you the varying cutout locations and zoomed in views of these. Then where it says existing wall studs, that's really enough information. But you might give me more information on the book, so the book says it's different sound if you have 1 inch or 1/2 inch gypsum board versus 5/8 inch gypsum board on the outside. So little details like that. I'm looking to see what would you add to the wall section in order to make it more acoustically sound. And then when I ask you for an elevation, I'm not expecting much. As I've already said, you can tell me the height, you can tell me the width of your room that's in between the meeting area. So just say 8 foot this way, and then this is going to be, let's say, 15 foot this way. And if you're in PowerPoint, you can just add a line and then a number above. It doesn't have to be fancy. I'm not grading you on your drafting abilities for this assignment. But then within this space, this is more of like the fun part of the assignment. So here, this is showing an elevation. We have a door, and then maybe this is an acoustical panel that's just a plain rectangle, and then it's showing the light in here. Really, I just want the acoustical panels. And they don't have to be plain rectangles. I want you to do some product development or looking up to find the coolest acoustical treatment that you can have on top of just the materials you're using. So if you're applying carpet to your flooring in one room because you think that's going to help with the acoustics, and you're doing a certain thickness of gypsum board, and then you have a special, very sustainable type of insulation. So think about why you're choosing products. I want to know some cool details about your section details. And you could take one and modify that. We do it all the time. I don't want you to get too hung up on the details of, you know, squiggly lines and what each one means and are you looking up the right one. We make decisions on just making up our own design symbols all the time. I'm more concerned about the products you think you need to apply. So we have the sections, and then down here it could be honeycombs or triangles, or maybe you just love Aurillac gray puffy paneling stuff. I mean, it could be whatever you want it to be, but some cool application that's going to let their company stand out because you applied it. And it's also going to add even more absorbing qualities to their walls. Does that make sense? Do you want more clarification? Kay says yes. You have to be specific in the clarification that you want.
So that's what you
Basically what I want, yeah. I mean, I didn't develop this elevation on my own. There's things like the drawings I want to show you as examples. My company owns them, so I can't take them back. But let's say I was you starting from scratch, and remember last week where I had that really cool acoustical wall application from Carnegie, and it was kind of like strange shapes like this? You could easily just do a rectangle, and it's not to scale. So if it's not to scale, just put NTS. That's not to scale. So I put not to scale. I do my rectangle. I might say 8 foot tall, 8-0. So 8. I want to see inches and feet. I'd expect you know that by now. And then I would do 12 foot marker, 0 inches at the top. And then on the wall, I might just get one of these to be the color and orientation that I like if it matches an actual product I found online. Copy it and then paste it and think about where I put my door. And you have a lot of freedom because I'm not defining the space for you. So you might say, you know, my door falls in the middle And here's why, because there's more reading than I was able to get to in the lecture today, but I don't want to have so much interrupted space, so I put my door here because I wanted to not add another flow of noise. So there'll be things you'll develop as you read through that I haven't mentioned. I haven't given you all of the points yet, but just giving me some type of cool layout of these within here. Now there's other things that aren't just tiles like that. So like I said, there's acoustical marker boards. There is acoustical wall coverings. You might just put a layer of wallpaper with a really cool pattern on it in one of these areas. This wall could be whatever you want it to be. It could be a combination of them. It's kind of up to you. So it's pretty loose assignment. I more so just want to see the research going into it, and then as usual supply me with some type of source sheet. So I'll just update this. So did I say that in here yet? Turn in drawings electronically, include image sources and research sources. There. How to clarify that. Anything else you want me to build into this?
No.
You want me to keep it on the screen?
It's time to
Hmm?
It's time to make.
All right, you guys are a closed-mouth bunch tonight. If you have any questions, you can feel free to email me, and you can always call me if you really want to get a hold of me faster. I work at school or teaching 8th graders until 12:30 every day, but other than that, I'm pretty available. Let's see what happens. Different assignment than we've had before. All right, I'm going to post this assignment, and then there will be a quiz. It'll become available tomorrow. It's just on my hard drive at home. So let me make sure I have all of you. Brianne, I think, is the only person I was missing before she came. When is it due? It's due at Wednesday at 5 o'clock. Does it not show you? Because here, I'm going to pull it up online. So if I go to Blackboard, acoustic exercise, because I set it with a due date, and I thought that it just shows to you guys on the screen.
I thought the assignments were due on Thursday before class. No? So I'm getting
No, you're not, Kate. I've been rolling in on the whole grading process. But so if I click on here, because I know I set the date, but I just don't know why you guys can't see it. Okay. So I'll try and include that more on the outside text of the file then. Because yeah, I have to choose a date before I upload it for you guys of when it's due, because then it'll tell me if you turned it in late or not. So I'm sorry that you haven't been able to see that, Shemaine. But yeah, Wednesday at 5 of next week. And then this class I didn't tell you, but I have a lot of you in another class. So your grades for midterms are due on Tuesday of next week for me, which means I will have everything graded and tell you what you have up to this 8-week mark. Okay? So be looking for those to come in. All right, you're dismissed.